Welcome to circular Waler math. First, why do we even need to do this kind of math? Well, if you were gonna build a silo or anything round like this out of concrete, we would need to build Walers and formwork all around it to make sure that we can support the concrete structure. And for that, we need to find out the lengths and the angles of all the Walers on the outside and on the inside that we're gonna need to cut. To do that, we're going to do some trigonometry and some Pythagorean. It's nothing new compared to what we've done in the last few videos. It's just a little bit of a longer process, but we basically do the same thing 3 times over. So no need to be afraid just yet. Having a quick look here, we have a radius given to us from the center to the outside of the concrete, right? And concrete's always given to the concrete edge. So that's 2,400, and we know that the wall thickness of the concrete itself is 300. Okay, so let's move on. Same drawing here. Just like before in trigonometry, we always want to work in segments, right? So we want to take pie-shaped pieces and figure out our angles, our radius, our lengths, the length of our chords, etc. So let's have a look at the specifications first. The minimum Waler throat needs to be 89 mils. So that means the skinniest portion of the Waler, that's this part right here, right? That's the parts outside here. The minimum width needs to be 89 mils, and same on the inside as well, but we'll get there after. Waler material is 184 mils wide, so 2 by 8. We're going to be working in millimeters. And then our sheathing, 2 layers of 9.5 mil plywood slapped together, which gets us 19 mils. Using thinner plywood allows us to bend it more easily. So the whole goal, again, is to find the lengths and the angles of the inside and the outside Waler for our layout. So then we can cut them, so then we can start to put things together. So let's get started. Step 1. What do we need to do first? First, we want to find the included angle of our segment. Now I'm going to be writing everything out, so it gives you a moment to kind of think about it and sort things out in your brain. So I'm just going to shimmy this over so I have a little bit more writing space. So the included angle, the radius that was given to us is to the outside of the concrete face, but the Waler itself starts on the outside of the sheathing. So what we need to do or find is the inside of the outside Waler radius. I know that sounds funny and that sounds confusing, but if you imagine, okay, this is to the outside of concrete, then it's the outside of sheathing. So outside of sheathing or inside of that Waler, that's the radius we need to find. So how do we find that? It's the outside concrete radius. So that's what's given to us with the 2,400 plus our sheathing. Let's pop in those numbers. We've got the 2,400 plus our sheathing, 19, will get us the 2,419. So that is our radius right here. 2,419. Awesome. Now, as in previous videos, what do we do next? We found our radius. Now we want to find our curve offset, right? So if we're going to be working within this triangle here, we want to find out how much this is that we can make sure that our Waler material actually works for us. So our curve offset, we have our Waler stock, that's the 184 mils, right? That's the 2 by 8, minus our desired Waler throats, the minimum, will get us this offset right here. So Waler stock minus our desired Waler throat. Let's pop in those numbers. We have 184, again, 2 by 8 given to us, minus our desired Waler throat. That's the 89, which gives us 95. So that is this number right here, 95. I'm just going to pop that in small there. Now, in the past, we've always wanted to find the adjacent side, so we're going to do that again so that we can work towards actually finding the angle here. So adjacent side, how do we find that again? Well, we have our radius that goes from the center to the very outside, minus our curve offset, sorry, to your radius right here, to minus our offset that we just figured out, and that will give us the adjacent side here. So radius minus our curve offset. And let's pop in the numbers. So 2419 minus the 95 that we just figured out right here gets us 2324. Now let's draw this in a triangle. I always find it very helpful to draw in little triangles of the immediate what I'm trying to figure out, because otherwise it gets a little bit confusing. So what do we have? This is the triangle that we're working with. We have our radius, and that is our hypotenuse, 2419. We just figured out our adjacent side, so 2324. And we are looking for the angle. Let's have a look at our SOHCAHTOA. So we're looking for an angle. Cool. We have a hypotenuse, so we're already within SO and CA, and we have an adjacent side. So we will be working within CA here, and we're looking for the angle. So if we blot out the C, it's adjacent over hypotenuse. Adjacent over hypotenuse. So if we're popping in those numbers, adjacent, so that's this guy right here, 2324 over our hypotenuse, that's our radius. And remember, I'll just write that in here, the inverted cos, because this only gives us a ratio, and then we want to punch in with the second function cos to give us the inverted, and that will then give us an angle. For me, that got me 16 degrees. And again, remember that this is what it gave us, right? That is only half the segment. So that means our included angle, there we go, is 16 degrees times 2, oopsie, which gets us 32 degrees, okay? Wonderful. So step 1, find the included angle of the segment. Cool, we did that, we found that. Now, step 2. We want to find out how many of these segments we have in our whole thing. So we know that a circle has 360 degrees, right? So number of, well, I'll just write that down, Waler segments. We know that a circle has 360 degrees. If we divide it by the angle that each segment has or takes up, then we'll find out how many of those we have. So divided by 30 degrees per segment gets us 11.25. Now we can have, just like in stairs, we can have one segment that's bigger or smaller than the others. They all have to be even. So we need to round up or down. But because we were given a minimum Waler throat, we can't go down because otherwise we're going to get below this number. So we have to round up. Okay, so that gets us 12. 12 segments. Excellent. So I'm going to move this aside so we can move on to the next step, which will be actually finding out what the included angle is, because we just rounded, right? So that means our degrees, our 16 degrees and 32 degrees, probably don't work anymore. So step number 3. Find the actual included angle and actual offset. So we are just going to do the exact same thing again that we just did, but with our actual numbers. So we have 360 degrees in a circle, and we have 12 segments. So 360 divided by 12 will give us the actual angle here. So that's 15 degrees. And this will be the number that we're going to work with from now on. Now the actual adjacent side, let's draw out the triangle again. Right, so this is 15 degrees. Our radius is still the same, that hasn't changed, 24, 19. And the actual adjacent side, let's call it A. We can do our trig again, so hypotenuse, looking for an adjacent side, leaves us with ka. And we're looking at the adjacent, so C times H. Okay, so C times H, which gets us cos of 15 degrees times 24, 19, gets us 23, 37. Okay, and that is now our actual 23, our actual adjacent side length. Now let's find our actual offset. Same as before, it's our radius minus our adjacent side. Radius still hasn't changed. 24, 19 minus our actual adjacent side, 23, 37, gets us 82. Now that's going to be our actual offset here. That's where I wrote the other one in so small, 82. There we go. Now we can check out the actual Waler throat because it's still 82 plus 89 does definitely not get us 184. So now we can work backwards to make sure that we're well within our limits, and mostly that we're above the 89 mils. So for our Waler throat, we have 184 again, right? Our actual material minus our offset will give us the leftovers. So 184 minus 82 gives us 102, which is definitely more than 89. So that means instead of 89, this will be 102, which make it a little bit bigger. So did that right. Super yay. Awesome. Let's move on to step number 4. We want to find out the actual Waler length. Now that we find out what the actual throat is, and we always want to find the long to long side. So from all the way to here, all the way to out there. Okay, so our circle is on the inside, right? So we have to do a little bit of extra math so that we can find out what it is out there. Okay, so this little triangle here is the same as these big ones. It's got the same proportions, and we are interested in what's happening up here. Mostly, we want to find out what the hypotenuse is, right? So then we can extend this line out and find a longer radius, basically extend our radius to the very outside, and then figure out the chord length of what's happening up here. So let's draw ourselves another little triangle so we can visualize what we're looking at. So we've got our 15 degrees right here. Our 184, that's still our Waler width. That's basically the adjacent side. And what we want to find is the hypotenuse. Okay, so adjacent and hypotenuse, looking up here, we're going to be working within CA, and we're looking for the hypotenuse, so adjacent over cos. Popping in those numbers, adjacent is 184 over cos of 15. Because the angle hasn't changed, it's just keeps on going on our line. Gets us 190.5. Okay, so that's this right here. 190.5. Now our full radius is our 2419 plus the 190.5, right? So 2419 was to here, and we just figured out this right here. Now I'm just drawing it over there so it's a little bit easier to see. So our full radius now, doing that math, will be 2609.5. So 2609.5 right there. Now can we find out the Waler length, the long to long point? Shimmy this up a little so I don't run out of room. Okay, so drawing ourselves another triangle. Well, the 15 degrees still hasn't changed, so that's easy for us. Excellent. So now this radius for the outside point to outside point of our Waler, this is the new radius that we want to work with, right? Because we're not working to the inside anymore. We're now working to the outside. So 2609.5. And we are looking for the half a chord of the Waler, just like we've done before, many, many times already. So we have an angle, we have a hypotenuse, and we're looking for the opposite. Hypotenuse and opposite means we can use so, and we are looking for the opposite, so sine times hypotenuse. So opposite equals, and we can set it up in the ratio and proportion again, so sine 15 over 1 equals to half our chord over our new radius, 2609.5. Ratio and proportion gets us 675. And again, that is half the chord, right? So half from here to here. And for our full chord, full Waler or chord, same thing, right? Is 675 times 2, which gets us 1350. Now we have enough information to actually go ahead and lay out the outside Waler. That is super exciting. So you could go into the shop or out into the field and actually start building and laying things out and cutting things. Let's move on to the inside Walers now. I'll also pull out different drawing here for inside Waler. And there we go. Hopefully you can see that. So now, step 5. What are we trying to figure out? Well, in overall, we want to find the length and the offset of the inside Waler. First, we need to find out what that radius was for the inside Waler. When you think about it, again, so our radius, the original radius goes to the outside of the concrete. So to get to the radius on the outside of the inside Waler, we want to subtract our wall thickness. So that's the 300 and also our sheathing again. And that's going to get us that radius. So let's write that out. So radius of the inside Waler. We've got the outside concrete radius minus the wall thickness minus our sheathing. Right, so let's pop in the numbers. Outside concrete radius was the 2,400. Wall thickness, 300, and sheathing, 19. Which gets us to 2081. Awesome. So that's going to be our inside Waler radius. So let's find out our Waler long to long point. That's what we want to find out. And it's always easier to find the long to long point for anything we want to lay out because we can actually hook on our tape measure. It makes it much easier. Okay, so let's draw ourselves a picture. Let's find out what we have. Do we have an angle? Yes, we do. It's still 15 degrees. What we want to find is half a chord. Do we have a radius? Yes, we do. Let's actually write that in here. Let me rotate that for you. That's our 2081 right there. Okay. All right, here we go. So what do we have? There we go. 2081. There it is. So as before, SOHCAHTOA, which one can we use? We are looking for the opposite. We have our hypotenuse right here. So looking for the opposite. O equals S times H. And again, we can set that up in our ratio and proportion just like before. So sine of 15 over 1 over half the chord over our radius, 2081. Ratio and proportion, sine 15 times 2081 divided by 1 gets us 538. Remember, that is only half. So for the full, it's 538 times 2 gets us 1077. Okay. Alrighty. Now, 1077, that's for right here. We want to find out our offset again, right? We want to find this guy out. So our offset in general is our radius minus the adjacent. Do we have the adjacent yet? We do not yet. Couple of ways that we can do this. Okay, so we can either do Pythagorean or we can use our trigonometry. Right, so if we want to find out A with Pythagorean, we would say A equals C squared minus B squared. Take the square root, right? C squared minus B squared, which we just figured out, gives us the adjacent. So 2081 squared minus 538 squared. And remember, you have to use the half a chord. Doing that math gets us 2010. Or we can use SOHCAHTOA, where we have an angle, we have a hypotenuse, and we're looking for the adjacent. So we would be working within cos times h for the hypotenuse. Plugging in those numbers, we would have cos 15 times 2081 gets us also 2010. So that's nice that those are the same, means we're doing something right. That's awesome. Okay, now we can go to our offset. Offset for is our radius minus the adjacent. So our radius 2081, I think I drew this in the wrong one here. My apologies. It's the 2081. Should be right there, not the short one. Sorry. 2081 minus, right? The radius goes all the way to out here, to all the way here. So full radius minus our adjacent side that we just figured out, 2010, should get us our offset of 71. So that would make this guy here 71. Okay, now we just have one more step left in our mathing journey for the circular Walers. We want to make sure that we can find the maximum throat for our inside Waler. Just to be sure that the 2x8 stock that we have is sufficient, right? We don't want to do all this math and do all this figuring out just to find out that it just doesn't work out. So the max Waler throat, how do we find that out? So we're going to work within this little triangle again, where we have the adjacent of the minimum throat. And again, the minimum throat here is actually the hypotenuse, because that's going to be kind of the minimum throat, like just the smallest number that we have available. So that needs to be the minimum of 89. So it's the adjacent, that's how you spell it, of the minimum Waler throat plus the offset. Okay, so let's figure that out. We're going to draw ourselves another triangle, last one, I promise. Again, 15 degrees. That still has not changed. And now it's the 89. That's our minimum measurement here. And we want to find out this guy, which means that's this triangle right here, right? So if we can figure out this, which is the same as this, plus our offset, then we can check if the 2x8 stock is sufficient. So we're trying to find the adjacent, and we have a hypotenuse. So again, we're within ka. We're looking for the adjacent, so C times H. Popping in those numbers. We've got cos of 15 times 89. That's our hypotenuse. Punch it into the calculator. Gets us to 86. So now let's see, 86 is this one right here, plus our offset that we figured out before. That was the 71, right, from here. We add those together. We get 157, which is a little way smaller than the 184 that our 2x8 material offers us. So that's excellent. That means our material is big enough to be able to use it. So that's it. Basically, we're doing the same thing 3 times, once on the outside to figure out our included angle and how many segments we have. And then we, same as in stairs, have to find out how big the actual angle is, and then do everything again with the actual numbers on the outside, and then we can move into the inside and do the same thing in here. So really, we're doing the same procedure 3 times. The math is no different than what we've done before. It's just a matter of understanding what you're looking for. That's the biggest one, and it's always been the biggest one for me, especially when you have long procedures like this. It's not hard once you understand what you're doing. It's just not losing track of what you're actually trying to figure out. As long as you can write it out every time, well, what's the next step? What are we trying to find, and why are we trying to find it? What's the end goal? Then you can always rationalize again and find your way through, even if your brain chooses to leave you for a while. Righty, good luck.